Hello and welcome back to the Astro Imaging channel. Tonight's session, I am going to cover, well, the title of it is Backlogs and Some Processing. And of course, before the session, everyone said, what the heck is a backlog? Well, I'll explain that in a second. But before I do that, I do want to show off our image of the week, which I was very impressed by. Must be a southern target because I'm not familiar with it. But this is one of those targets that makes me want to somehow get my hands on either the data or get a telescope down in the southern hemisphere because, wow, it's impressive. Looks like a combination of emission and reflection nebulas, and the processing job just did a great job. Diego Colanello, another image of the week, just really impressive. You can check it out on our website, theastroimagingchannel.com, under the tab Image of the Week, and it will, you can comment on it, or you can read the description of it. The one thing that stood out to me was it was a 10-inch f4. So he's using a really large, really fast scope, which probably gives him a lot of resolution and that speed. We were just discussing a scope similar to this before the session, which is putting out some good images, and we're excited to see what comes from it. But yeah, hop on the website, give Diego a shout out, just leave a comment there, say congrats, nice image, wow, whatever it is you think you want to do. And as always, might as well show this off. If you want to get in on this chat, go to our website, theastroimagingchannel.com. If you're on YouTube, we don't monitor the YouTube chat. Click here, and you're in the chat. You can open the box up and have it, I don't know, pop out so you can watch the session while you're chatting and just enjoy the show that way. But of course, we like it when you do it that way because it gets you into the chat and participating. Taking my screen back. Okay, so like I said, backlogs and some processing. So the primary thing I'm going to do today is do kind of a walkthrough of an image that I've been processing. But before the show, somebody said, what's a backlog? And here's a backlog. When I started imaging, I was basically shooting one image a day. And as soon as I got, I shouldn't even say one image a day, a few hours per image. So I might even have 2 or 3 images by the end of the day. And I would come inside and I would stay up till 2 or 3 a.m. and I would process those images. And the next day I'd probably post them at 2 or 3 a.m. on Astrobin and cloudy nights and show them off and get my feedback. But then I started shooting much longer exposures. So I would end up shooting, I don't know, 16 hours, 24 hours, and it would take 2 or 3 days worth of data to have an image to process. Sometimes I would rush in, I would process the H-alpha or the RGB or some component of it just so I could see what I've got. But what ended up happening was I kind of went from having 2 or 3 okay, not so good images a day to having 1 image every few weeks. And it was a much better image. The quality of the data was much better because I was putting in that much more time, but it was taking a lot of time. So I really had to find a way to make myself more efficient, and not in my processing, but in my acquisition. So what I ended up doing was I got a automation program, and you've heard us tout this program before, but I'm going to tout it one more time. For me, the automation program was Sequence Generator Pro. What it basically let me do was not just plan out my sessions long in advance, but it gave me a little bit easier way of framing so that if I was doing either mosaics or trying to get a new perspective on a target, it really offered me that. Sequence Generator Pro is the way I went for my automation. But you don't have to go that way. There's lots of options. We've seen recently the StellarMate, which is kind of an all-in-one Arduino-style computer that you hook up your camera and a few other devices to, and it basically runs your whole entire imaging session. But so where am I going with this? You need to get more efficient to get more data out of it. But when you start going to automated acquisition, you can also start looking at your acquisition slightly differently. Your targets are going to rise and set, and maybe you're going to get six or so hours on a target. And if you do have a second target lined up for that night, well, you're going to start putting in a few more hours on that target as it rises. So say you get 6 hours on your primary target and 3 hours on your secondary target. And as you're working on that primary target and you're finalizing that, you're getting a little bit more time on your secondary target. Next thing you know, you might finish both of these objects at the same time. You might be working on a third target. And basically what you're doing is you're building a backlog of data. You're not quite sure when you're going to be satisfied that you have enough data on one particular target. What's worse than that, you might not be satisfied with the amount of data you get through the entire season. And you may be looking for whatever you get in the next season to finalize it. That's happened with me, particularly on mosaics of the Orion region. Because the Orion region's low, I don't get much time, and it actually passes right in front of a tree in my yard. So maybe I get 3-4 hours if I'm doing wide field of clear Orion sky. So what I end up doing is I go year to year, and I end up building that backlog. And if I look back 3 years and I have properly stored my frames, whether they are calibrated or uncalibrated, but I have my flats properly labeled and my darks labeled and my bias labeled, so I know where I have to go to properly calibrate them, then I can combine them with this season's data. And in some cases, I combine them with data from a different season, even if it's a different setup. So what do I mean by backlog? Well, I guess that's what I mean by backlog. If you've been imaging for more than just a year or two, you've got lots and lots of data, probably on the same targets. And what you want to do is you want to be able to utilize that. And automation really gives it to you. Sometimes let's see, which screen are you guys looking at? You're still looking at that screen. Oh, it almost looked like you're looking at a blank screen. Okay. Well, you are at the same time going to see how much data I have and how disorganized it is. But, and this is my, let's see, this is what I've got since about mid-2015. I archive a lot of data just to save space on this drive because it's my primary drive. But I do try to label it object at a time. And most recent object, SH2104, I can see here that I got 18 H-alpha frames and approximately 20 of each RGB frames, which, if you ask me, that's about what I would aim for data like this. So what I'm going to do is I'm going to jump in and I'm going to process this. Yes, we've ended the backlogs part of the conversation. We're just going to jump right into processing. Oh, I forgot I used the full screen share for that too. I'm going to show it off here first. This is my end point of the first walkthrough I had of this data. And I've got it nicely noise reduced. There wasn't much noise to begin with, so it was a pretty easy object to work with. It is an H-alpha RGB object, or excuse me, image, but it's also an object that's very conducive to that H-alpha RGB processing job because there's no reflection components to this. It's basically all emission nebula. It is an emission nebula in the Cygnus region. So I guess you could say it is among the most boring objects in Cygnus, but it's also one of the most, or one of the most infrequently imaged objects in Cygnus. So that's what it looked like when I finalized. I will go through and show you some of the issues I had. First of all, when I first combine it, you're going to see my stars took on a hue that I did not like, and I really had to mute them. I think I could get better star color out of it if the processes worked a little bit better than they did for me. But I actually did them over and over again, and I couldn't get them. Maybe someone can suggest something during this session. Give me some advice that I probably won't take. I'll probably do it my own way, but just say, hey, this is what you're doing wrong. Maybe something will stand out to somebody. So I'm going to jump right in. Open the data up. If you guys have any questions as I'm going through this, just post them in. If someone in chat, in the room would monitor the questions just so they could call them out to me. I'll try and check every 5 minutes or so. Excuse me as I take a big drink. So I open up the frames, and basically the first thing I do, even out of just my combination, is put a quick screen transfer function on them. I'm doing a Control A to put the auto stretch on them, the screen transfer function. That's why they pop up and you see what's in there. Just a shortcut, keyboard shortcut. So I've got my blue, red, green, and H-alpha. We'll leave the H-alpha off to the side. So for you beginners, what the heck am I talking about? Screen stretch. Whether you're an astrophotography beginner or a PixInsight beginner, the images after combination start out in what we call linear. I don't want to say format. They start out linear. In other words, the brightness represented in the image should represent about how many photons fell on that particular pixel. Works really well scientifically. Science really demands a linear image because they're going to be counting those photons, and they rely on the sensor being efficient enough that they can count those photons. But we're not really doing science. Our data can be used for science, but we're basically making pretty pictures. So rather than having this, rather than having this scientific image, we'd rather have something like this because it's a little bit prettier of a picture. That's my quick explanation. So that's my beginning explanation of keeping an image linear and then bringing it nonlinear. Nonlinear basically shows you what's in the image. Keeping it linear preserves the scientific integrity. If you're producing a pretty picture, no reason to keep it linear. That said, we try and do some of our stuff in a linear state, and you'll see what exactly we do that way. Jumping right in, still linear image. First thing I'm going to do is I'm going to run a linear fit on them. I think we typically use the green channel. Some people use different channels, but I'm going to quickly put a linear fit on all of the frames here. Linear fit normalizes them, so in a linear state, it kind of aligns the dark and lightness levels so that when I combine them, the color representation is a little bit more true to how it was acquired. But again, this is all linear, so it's basically a slight fitting function that's happening to the images. I'm still going to, if I want to see the stuff that's in there, put that screen stretch on there. Again, just so I can see what's in there. I have now all these images fitted, and just for the sake of it, it doesn't even matter if I use the H-alpha, but I did. Shouldn't matter one way or another. So I have linear RGB channels. I do my combination of my RGB channels while it's still linear. And Pix Insights channel combination tool really is the best. Still has the channel saved in there. Excuse me, the channel name saved in here from default. If it wasn't, you'd have to plug them in there, but it is. So bam, it pops it up. It hasn't put a screen stretch on it because I don't need a screen stretch on it, or I shouldn't say that. It's still linear. I need to put it on manually. So I put the linear fit on it, which means that when I link the channels there, it should turn out kind of okay looking. It should look pretty similar to what would happen if I unlink the channels. Yep, exact same. So immediately, you're going to see what I was talking about with my star colors. Probably my biggest struggle with this image, the large stars had a kind of ugly green hue to them. In fact, all of the stars have kind of an odd green hue to them, which just didn't really do it for me. One of the cheats that you could use on this would be to, since there's no real green stuff in space, I can kill the green using SCNR, which I'm going to have to jump down to right there. Green really just is unattractive in astro images. Some people have difficulty actually seeing it in their images, but I think as you get used to astrophotography processing, it starts to stand out. And this typically removes it, whether it be just a component of a gradient or something that caused that. For me, I'm not quite sure what caused it. My initial thought would be possibly some clouds moved in on my green channel, or maybe my green channels were shot a little bit low. But whatever it was, this should at least neutralize some of it. I'm going to run the process quickly, and bam. I don't know if you saw how dramatic that was, but it killed it. It looks a lot better. It looks 100 times better right now. Green out. I've still preserved what I want, which is basically kind of that diffraction effect in the spike where you get the different color tones, which I may try and play up in a little bit. But just using that SCNR, I killed all that green, and now I'm going to jump right into attempting to color calibrate. My old method for color calibration was background neutralization and color calibration. I'm going to run this really quickly just to show you how I would do it. Background neutralization, I'd take a preview of just background sky, no stars. Where am I going to find that? Right there. It doesn't have to be huge. That will do. The larger the sample, the better, but I'm not going to find a large sample in this image. I can combine a few background areas using a particular script, but this will be sufficient because I'm actually not going to use this because there's a newer tool that I use for the first time and I actually prefer a little bit. But here we go. Neutralize the background. Then I need to color calibrate. Background neutralization and color calibration are kind of used together. Neutralize the background there, color calibrate using the target image as the white reference. Since there's no galaxy inside it, I use structure detection, which picks all the stars and tries to balance them that way. Background reference, I choose the same preview that I had used in background neutralization, and basically I just run it on that image. Going to take a little while as it works through 3 channels. I'm going to pop back over and look at the questions if there are any. Looks like they're unrelated, so I'm actually going to just ignore them for the time being. Ran color calibration, background neutralization, linked the channels, screen transfer function. I've got some decent star color there. Now, one of the things that bothered me with this image was some of the stars were coming out very red. And that's what caused me to want to try this new tool. And I will say this, even though I use the new tool to get rid of the red stars, it didn't eliminate the red stars. I think some of them are actually supposed to be that red. This one in particular, I think the color of it is just actually that red. That said, I think in general, all the colors of the stars have shifted, possibly someplace that I'd rather them not go. And in the end of this, I might use what I'll call a borderline destructive process to kind of make the stars look better. But it made the stars look better, and it didn't necessarily throw the balance of them off. So there we go, color calibrated, background neutralized. But I'm not going to use that. I'm just checking my time. What I'm going to do is I'm going to use this as an opportunity to show off that new tool, which is Photometric color calibration. David Alt had demonstrated this tool I don't know, 3 months ago, 2 months ago, and it's pretty cool. Some people use G2V calibration. Some people use Photoshop's, PixInsight's calibration, which is kind of a relative calibration. It doesn't, I don't want to call it a dumb calibration, but it's more intended to the pretty picture side. There's no desire to maintain scientific integrity in the distribution of colors of the stars, whereas with this calibration process, there is. And for those of you that use G2V or a process like that, you for that reason, to keep it more scientifically relevant, then I think you might appreciate this more. So basically what it does is it solves the image and then basically identifies each stars and distributes the colors that, or I should say, fits the proper colors to each of those stars. What does it need for that? Well, it needs to know what the field is. So I'm going to reset the tool, and you can see here, what is this? It wants to know the object coordinates. Why? Okay, because it actually has to know what the stars are. It could do a blind plate solve, but better to give it a little bit of a hint, right? What's the easiest way to hint? Well, this image, because it's RGB, is going to be a little bit harder for it to solve. So let's cheat. Let's just steal back our red channel. Oh, I'm sorry. Nope, I don't want to steal back our red channel because I need to give it a better hint than that. What I want to do is I want to take one of our red subs right there. And just by acquiring from image on that active image, it knows what was embedded in the fits in regards to focal length, pixel size, observation date, and coordinates. It knows what's in the field. It knows at least close to where the field is. My acquisition program, because I configured all of those, sets it in there. Makes it that much easier. So basically, I'm going to run this script on here. Remember, I undid the other color calibration. I'm redoing a different color calibration. It is plate solvent, Yep, Alex, I think you just got the answer to that, right? The photometric tool, read the header regarding position of object. Yes. Yeah, for those of you that are looking for beginner questions, we try and answer a lot of beginner questions here. I do really suggest finding a forum, and the one that would be most suggested by all of us would be Cloudy Nights. Lots of people on there that are willing to help out and answer all those beginner questions. You know, the same beginner questions get asked over and over and over again, and while it may frustrate some, people willing to answer those questions. And you can do some searching on the forums. You can look at the best threads or best posts and get some info in regards to that. Or you can just ask your questions and hope that someone's willing to walk you through it. Try and the topics a little bit more. It's not that we don't have open sessions where we do that. So there we go, white balance. Oh, so that's odd. It didn't fit it the same way it did last time, so I wonder what changed. I don't quite see what changed from here. So I'm probably going to run with it. I've got my RGB image here, but it's still linear. What I'm going to do is, well, I need that back. Take my screen transfer function back, and I am going to attempt to use masked stretch. When I have good star color that I don't want to blow out, or at least I know that I need to try and keep my stars under control, I'll use the mask stretch tool as opposed to the histogram transformation. If the mask stretch doesn't work for me, I'm going to switch over to the histogram transformation. But there we go. I'm using mask stretch. I actually put it on with screen transfer function on, so I hope I didn't mess that up. And I messed it up. Screen transfer. Mask stretch does a good job of keeping the out. I want to do on this because this is where I'm going to get all of my color from. I use this component of this because my H-alpha is much cleaner. Originally H-alpha, the want all the detail that the H-alpha is going to provide. %78 done, so working our way through. Yeah, so I'm demonstrating monochromatic processing. Somebody's asking about one-shot color in excuse me, in chat.
Adam,
yes.
I'm monitoring over there, and I don't see much that would be that's related directly to your discussion. So I think we're kind of having side conversation occasionally over here. But you're right. There are some topics that are really hard to answer, and we've actually devoted big shows to them, like what kind of camera I should buy. So I don't think you have anything over in chat right now that you need to worry about.
Sounds good. Thank you. Yeah, like I just want to say I do use monochrome. So this combination of channels that I'm doing is more the monochrome technique. From the point when the channels were combined, that's where it's basically the one-shot color technique. but monochrome cameras are going to be more efficient for a number of different reasons. If you're going with a CCD or a CMOS, I really think mono with filters is the way to go. So here I have my nonlinear now RGB channel. You can see a little bit of the nebula in there. Basically, though, what I needed here was the star color. It's really the only thing that I care about. So I'm going to not necessarily put that aside. Well, maybe I will put that aside. I'm pretty much done with these channels, so I'm just going to put them in the background. Now I have my H-alpha channel. Now the H-alpha channel I'm going to have to pay a little bit more attention to. Let me get rid of a few of these windows. All I want is screen transfer function. I'm going to try the mass stretch on this too, but I actually have a few things I want to do. First, there's a touch of noise in the background. I think that at this early in the process, I want to mute just a little bit of that noise. So what I'm going to do is I'm going to make a copy of this image. I am going to make sure the screen transfer tool has that stretch stored in it, and I'm going to drag it to the histogram transformation tool. And then I'm going to apply it to the clone that I made and undo the screen transfer function. So now I have a nonlinear version of this linear image that I'm basically just going to use as a mask. I don't, and I might actually put a little bit further of a stretch on it to, oops, lighten the lighter areas and darken the darker areas. Just put that little bit of a stretch on it. And then I'm going to apply it as a mask to this image. Invert it. So the nebula is almost completely protected. The stars are basically all protected. The only spots that aren't protected are some of those dark areas right there that had a bit of a granulation in them. And I am going to use what's probably the most old-fashioned kind of cheater way to, and when I say cheater, just kind of a simple technique to mute some of that granulation in the dark areas. The Atrus wavelet transformation, very old tool. The starting technique that I've seen, first of all, I am going to hide the mask so that I just see those little bits. The technique that I've seen, you start with the largest component, the largest wavelet layer for threshold 3, which I believe is default. Let me reset the tool and walk through this. Wavelet layer 4, check noise reduction, threshold 3. I'm going to bring this, I'm actually going to bring this way down. I'm going to start at 30, but I'm probably going to drop it further. Noise reduction, threshold, drop it to 2. Amount, bring it way down to 30. I'm going to be tweaking this, like I said. Threshold, bring it down to 1. Amount down to 30-ish. This layer barely does anything. But in that range, gives me a good idea of what it's going to do. This tool you want to use gently. I'm using a shortcut to generate a preview. Oops. Maybe I'm not using a shortcut to generate a preview. No, what am I doing here? There we go. That second one's going to bother me. Sorry. Control N, not Alt N. Or Alt N, not Control N. So what I want to do is, I don't want this to change. I don't want to lose any detail in here, but I want a little bit of that granulation to disappear. So I drag it into the preview. I'm going to see what happens. I would only expect a little bit because that mask is protecting a lot. Just a little bit, but it might be, it's looking to me like it's possibly too aggressive. I don't know. I might need a different perspective on this. Yeah, I don't like something that's going on there. I'm going to bring my amount on all of these way down. It looked like it was in the larger scale, so I probably should have only brought down the larger scale, but I really just wanted a touch, which I think I've got right there. I'm not losing any detail. I barely see anything except for a touch of that granulation in the background, or a touch of that graininess in the background to disappear. So I applied it to my full image. I can get rid of that preview. I did a slight noise reduction on the linear image. Remove my mask. Put a new stretch on there. And let's do a. I actually like what it did to my stars there. Let me work with this and see if further histogram transformation will keep the stars in a little bit better. Oops, generate a preview. So the histogram transformation function basically is just a screen stretch. Kind of like the way that looks right there. I will still have nonlinear noise reduction to do, but let me keep moving on. The first time I processed this image, it took me about 2 hours. I'm trying to do it now in about 45 minutes, so it's not going to come out quite as well as I hoped, but hopefully the second walkthrough means that it'll be a little bit better. So I have a nonlinear H-alpha image here, which I'm going to use as my luminance component for that RGB image that I hid or I put off to the side somewhere. Right there. Let me put it off to the side here. Got, nope, not that. I think that's it. Yep, that's it. So let me see. One little thing that's bothering me. I'm not great in, not great in PixInsight with the curves transformation. And I'm actually not going to use it yet. I'm just reminding myself, not going to use that yet. So I have this nonlinear image. What do I want to do right now? Right now, I want to get a little bit more detail in that nebula. There's a lot of detail in there that I'm not really showing off. But what I really need to do is I really need to focus whatever process I'm going to do on that internal nebula. So I am going to copy that image there, and I'm going to do one of our old-fashioned tricks, star mask. I am going to try and do a star mask and get all of these stars in it, including the large ones. To get the large ones, I boost the scale up. Noise thresholds at 0.35. 0.35 to 0.40 is what I use for nonlinear images, and it usually comes out pretty well. When you binarize it, you're getting more protection on the stars. Basically, all of the star is protected, and the threshold is determined by the smoothness factor there. So I can't say I know whether you increase or decrease the smoothness to make that threshold cover more or less of the star, but I usually use 12, and it usually protects the star well enough for this particular process. That scale is determined by the size variation of the stars in your field. Scale structure growth, when you're not using binarize, will grow the protection around the star, or around the larger stars, small scale around the smaller stars. %. Hopefully this mask turns out well. The star mask process takes a bit of time, but once you learn how it works, it is absolutely irreplaceable. In fact, as you'll see, sometimes I will create a star mask in PixInsight to drag over to Photoshop. Oops. I'm sorry, I'm just seeing this. Okay, yeah, so what am I doing? I am missed. Applying the star mask to my cloned image there. I think that by inverting it, you get you get a better idea as to whether it's working. Are all of the stars that you want protected? Basically, in this way, all I really wanted to do was protect all of the stars, but I want to run the process on the stars. So I need to again invert the mask, but I'm also going to remove it or to unshow it. I am going to do one of our favorite processes, morphological transformation. What I'm going to try and do is I'm going to try and remove the stars or get rid of a lot of the bits of stars in kind of a quick sweep. Morphological filter using erosion. One iteration, amount can be anywhere between half and one whole. Structuring element, where is it pulling the replacement data from? The larger the element, the more it reaches out away from the stars. You just want to experiment with this. I also use a circular structuring element, which means it kind of pulls them in a circular way. What's it sampling and what's it pulling the new info from? So I'm going to run this quickly on this, and you should see the stars basically almost disappear. Let's see here. They went from that to that. Still some stars in there. So let's increase the amount and see. I might have, and that's going to be too aggressive because you can see the holes around the stars. My star mask could be a little bit better. I'm going to change the structuring element. See if this changes anything. Yeah, I've still got some holes in my stars. I think my best results were at that 49. What I'm doing right now, I don't have to be really precise. You'll see why. I'm not really trying to remove the stars to make a I'm not really trying to make a pretty image here. All I'm really trying to do is, well, I'll show you right now. Stars masked. I am going to go to the most destructive tool in the PixInsight toolbox, convolution. And basically, I'm going to remove the stars. I'm sorry. I'm going to blur out those stars. Stars kind of blurred out. I'm going to remove the mask. Run that convolution again on the image, the whole image. And you're wondering, what is he doing here? Well, basically, I just want the nebula and a little bit of that nebula to show up as white. Why? Because I'm making a mask. I'm making a mask just of the nebula. If I got more creative, I could be really thorough when I do this and actually use this as a large-scale component and add detail to my image later on. But what I really wanted to do is I wanted to set myself up to do this next process. If I was being really thorough, I would get rid of that star. I'm not going to do that now because I can see I'm already running low on time. I'm going to run a quick curves on this because I need to darken. There we go. Darkened. Going to apply it to that image as a mask. Going to show it. You can see it's masking off what I want to. Oops. I should say it's masking off not what I want to. So I'm going to invert it. Do that. Go to HDR multi-scale transform, which is what's going to allow me to bring a bit more detail into the nebula here. To lightness mask. Number of layers 6 tends to work well for an image like this. For a tighter planetary nebula, I might use lower layers, lower number of layers. But I'm going to apply this, and we're going to see what it does. Don't know if you could see that. It's kind of subtle. But it did give me a little bit more detail in there. Let me drop the number of layers, apply the same. So what's happening is the mask is actually not, the mask is, I think, a little bit too aggressive. I'm going to have to lighten up the inside of the mask just by putting a stretch on it. Lighten that, darken that. Same mask still applied here. HDR multi-scale transform. All right, so that was a little bit better. My stars are protected. I got my detail out of that. Next step, local histogram equalization, which I will keep the amount really low on. Default amount is 100. I'm going to drop it down here. I'm going to apply quickly. I do not think this will take a long time than I expected, but we'll wait through it. And I'm going to see if this in the dimmer areas, or I should say makes the bright areas just have more contrast in general. Seem to help a bit more too. as I toggle back and forth. I hope you can see that. It does seem to help out. So there we go. I've got my image. Basically, what I'm going to use is my luminance component. My mask I am pretty much done with. I am going to remove this mask. I'm looking at that, and since I've gone with a little bit more of stretching and whatnot, I did work a little bit noise into that. Before I work on the noise, though, I'm going to use one of my favorite scripts, just because it's so easy and it tends to help the image a lot. Dark Structure Enhance. I just run it on there, and what it's going to do is it's going to enhance dark lanes. It's going to enhance any dark dust structure that is either in front of the nebula or in front of the dimmer areas. There we go. Let me show you what it did there. So look right here and look up here. Definitely enhanced it a bit. Gives you just a little bit more interest in the image. Makes it look like there's just dust flowing out there. Definitely going to help in the final image a lot. Working my way through, I am going to go to ACDNR, which is one of the easier noise reduction tools to use. First thing you do with ACDNR, or one of the reasons it is so easy, is it actually gives you a mask generation tool at the bottom here. Click Preview and click the Preview button, and you see the mask you're generating. This is the default here, so I'm going to click Preview, and what I want to do is I want to drag the midtones down. Basically, the spots I want to reduce the noise on should be white. The spots that I want to preserve the detail on should be black or darker. Gray means a little bit of noise reduction. You really just want to play with these. You don't want super harsh transitions, but you do want to make sure you get enough noise reduction in the areas where you did notice some noise. That's probably where I'd be happy with the mask. I'm going to pull it back. I look at this. It's only lightness that I'm worried about because it's just a black and white image, grayscale image. Looking at the image, noise reduction looks a bit aggressive. Standard deviation, how large the scale of the noise reduction is. So I'm going to pull down the amount. I like a little bit of noise in my image, so I'm going to pull down the amount kind of significantly. This is the preview, so it's a little hard to tell from that. Generate myself a box. Apply the noise reduction to it. Let's see, how did it do? Got rid of a lot of the noise. Interestingly, got rid of the noise at a different scale than I was expecting. Oh, have to tell it to use the lightness mask. Okay, let's try this again. There we go. So I toggle this back and forth, and what I'm looking for is I'm looking at the dark areas here and make sure that it reduces the noise, and I'm looking at the light areas here and I'm making sure it doesn't kill any of the detail. It's not touching any of the detail there. It's going a little bit soft on the noise right here, but I'm kind of happy with it. I think it's going to process nicely, so I'm going to go back to the big image. I'm going to apply that there. Process its way through. I already know one of the problems I'm going to have here, so I am going to try this quickly and acknowledge that it's going to be an issue. That's my RGB image. This is what I was hoping for to use as a luminance image. So what happens when I combine channels? Channel combination. I want to only apply the H-alpha. One integration. H-alpha binning, one integration should be that one right there. What's going to happen? My color's going to be off. Oops. Picked the wrong image. Let me do this. This will make it easier on me. I'll just apply it to that quickly because I think I know what's going to happen. I think my color balance is going to be way off. And this is where you have to get into a bit of a cheat. Since I'm, yep, look at that. Color's awful. Cheated, saturated, probably wouldn't be enough if I did like a color saturation. I don't think I can saturate it in a way that it would be attractive enough. I'm going to have issues with the star color and the nebula. So basically what I would end up doing is, oops, take that back. I am going to extract the RGB channels. RGB. I am going to go to my favorite tool, Pixel Math, and I am going to take the maximum of the R and the H-alpha channel. Let me identify this as R, and let me identify this as HA. I'm going to create a new image. It's going to be RGB color. There we go. So all of a sudden I've combined using the maximum function or the lighten function to create my new R channel. This works because this image is primarily H-alpha. There's no reflection component, so it's basically reds. So let's see what happens here when I go back and combine the channels that I've just... Oh my goodness. Gotta learn my alphabet. H-alpha is my new R. Oops, did it take it? H-alpha is my new R channel. Green and blue. And there we go. Pretty heavily red. I might want to mute some of that red. But I'll tell you, it's pretty darn close to what I was hoping for. My stars, I'm going to have to do something funny on. Did I lose my star mask? I did. Let's see if I could just do this. Color saturation. I must have a star mask around here somewhere. So what do I want to do here? My stars just, they don't seem right. They seem too red. So what I'm going to do is reset the tool. I am going to say, I like how it looks when it comes to green. Kind of like how it looks when it comes to yellow. I like how it looks when it comes to blue and purple and all that stuff, but what I don't really like is how it looks in the reds. So I'm going to pull the reds down. Try and kill some of the red in just the stars. I'm not sure that is working, and I don't quite know why. Maybe it did kill some of it. I could always increase the range and pull it down more. I don't, there's something I'm not picking up on right now. Is it, no, I think that is working. It just muted some of the reds, but I don't know, it looks pretty good. So I'm just looking at it, and oops, I'm going to remove the mask one more time. Oops. Oh, my goodness. I'm going to run that dark structure enhanced script one more time, because I think in that combination process I lost some things, lost some of these lanes, and I think it's going to be able to pull them out a bit better. It really works magic. So what am I doing today? I'm just kind of walking through a process related to the backlog thing, but some people just want to see how we process. It's been a long time since we've done it. Yes, look at those lanes. Look how it brought out those lanes even further. Maybe gave me a little noise. I might choose, if I were doing it all over again, to do this process, do it again, and then use the darken function to kind of get rid of a little bit of that noise. But got me here. What do I look for in an RGB image when I'm combining with H-alpha? Basically to preserve the star color, and also I like that diffraction spike. I like the color in that diffraction spike, how it retains that. What I almost always do is I'm going to save it off the TIFF file in 16-bit, bring it over to Photoshop. You can see versus my last process how different it is, actually. I did a better job with the stars. I kind of like the colors. I like the detail in this one a bit more. So I could always combine it for detail. Let's see how the color components work. Let's see what would happen if I did that. What I would probably want to do is copy all of that, paste it in a new layer, possibly using darken. Let's see. Maybe. I'd have to think about that more. I get some detail back, but what I'm doing right now is I'm actually running down a sidetrack. This looks pretty good. The one thing I'd probably do on it is if I chose not to use PixInsight to make the stars smaller, I'd probably use the astronomy tools action, make stars smaller. Might run it twice. And there we go. I mean, I've got a decent looking image. Looking again at it, I would definitely want to go through, spend more time trying to get more detail out of that. Probably with using the HDR, excuse me, the HDR multi-scale transform tool and local histogram equalization. I could use this on different scales. I can use this on different scales and just kind of work a little bit more of that out. But that's basically it, the walkthrough of a process of how I process my data. And I don't know. I jump back over. Hopefully you guys enjoyed this one. I don't know. I hope it seems like there was a point to it, because basically I was just walking through my process of the data. But that's it. Can morphological transformation be used on objects like the Veil Nebula to make the nebula more prominent? That's a question for David Alt, because I'm sure it could be used on the Veil Nebula to make it more prominent, but not as simple as something like a star, which I think morphological transformation is more intended for. HDR multi-scale transform and I'm sorry, I always forget this tool's name. Local histogram equalization gives you the allows you to make to display more of the structure in there, more of the structure that's kind of buried in the lightness. So that's it. I don't see a lot of questions, and I see a lot of, oh, so-and-so left the group. I hope this wasn't a boring session. Maybe it was. You know, we're all at different points in our imaging. We have a lot of really talented people on here that probably knew everything I was describing and didn't need to watch that. That said, I hope a few people saw it and said, ooh, PixInsight looks interesting. New local fuzzy histogram hyperbolization. No, I haven't used it yet, but I'm going to have to look that up, because I think I know what it's going to do, and I think it could work a little bit better than what I was doing. But I'm going to have to play around with that one.
Isn't that the one that brings up the, preserves the color saturation better?
Possibly.
Yeah, I think so. It's one of the new ones that just came out last couple of weeks, or last couple of months.
Couple months, right. Yeah, I will check that out, and if I have any good luck with it, I'll report back, because it's those specific tools I think are the most valuable. You don't realize how much structure is buried in there, and if you image long enough, if you take a long enough image overall, you've got all that data in there, and basically bringing out all the nuances in luminosity. Yeah, just that's what makes an image. So there you go. Hope you enjoyed the session. I don't have anything specifically scheduled for next week. If I do, well, I always post it as soon as I come up with something. If you guys have any ideas, let me know. That said, have a good night. Till next week.